Okay, so we learned how to identify and write numbers and identify the number of significant figures. Then we often do calculations with these measurements. And when we do a calculation, we need to know how to report the answer so that it reflects the amount of precision involved in the measurements that went into it. And there's different ways to do this. We're going to use significant figures. This is not a perfect technique, but it's actually the simplest effective technique. The other way to do it would be differential calculus. How many want to learn the differential calculus method? Yeah. Not too many, okay? I learned that in college, and then after the final, I promptly pressed delete on that part of my brain. I could figure it out again, but I don't ever use it. Significant figures, once you understand the rules, are really much easier. So when we do a calculation, our calculator will often give us a whole screen full of digits. We need to be smarter than the calculator and round that number appropriately. Sometimes we have calculations where we do multiple steps. You add these two numbers together and you take those, then you divide by something else, and then you square it, or you do all these different things. Different steps of calculations. If you round each calculation, you can introduce error into your result. So what we want to do is we want to save the rounding for our final answer. So there are two types of operations that we run into a lot. Multiplication and division are opposites of each other, and then addition and subtraction. And so there's a different rule for each of these. So when we're multiplying or dividing, the result is going to have the same number of significant figures as the factor with the fewest number of significant figures. So I brought my calculator, and we're going to do, I don't have to do it because I already wrote the answer. I was thinking ahead. So if we take this 5.02 times 89.665 times 0.10, our calculator will give us this. It might give you some more digits too. We need to know how to round this so that we don't inadvertently tell someone that we know this answer more precisely than we actually do. So what we do is we look at each of the factors. So 5.02, and we ask ourselves, well, how many significant figures are in the number 5.02? There's 3. How about 89.665? 5. 0.10. 2. That's the hard part. Which is smaller, 3, 5, or 2? 2. This is the number with the smallest number of significant figures. That means I need to round this answer to 2 significant figures. So the first digit that's not 0 is a 4. So that's 1, and then 5 is the second one. So I'm going to keep the 4 and the 5. We'll talk about rounding in a minute, but I'll talk about it now as well. Look at the next digit. If it's less than 5, you round down. If it's 5 or greater, you round up. So this is going to round down to 45. It's not good to write this whole thing out because this number here only had 2 significant figures. So this wasn't a very precise number compared to the others, and so that limits the precision in the answer. Let's look at the one on the bottom. Here we've got 5.892 divided by 6.10. Calculator gives us this. So we're going to look at the first number and ask ourselves, well, how many sig figs in 5.892? 4. And how many sig figs in 6.10? 3. Which is smaller, 3 or 4? 3. That's how many significant figures I should have in my answer. So I've got the 9 and the 6 and the 5 is the third one. There really should be a 0 here. Scientists always put a 0 before the decimal point in a number that's smaller than 1 because it helps draw attention to the decimal point. Decimal points are really small and it's easy to overlook them, especially if someone's writing and they have a really sharp pencil. The 0 calls attention to, hey, look, there might be a decimal point here. Would this 0 count as a significant digit? No. It's just they're calling attention to the decimal point. So then we look at the next digit that we're going to get rid of. Are we going to round up or round down? We're going to round up because this is closer to 0.966 than it is to 0.965. So this is 0.966. Any questions? So here are the rules for rounding. You're only going to use the first digit that's being dropped. Don't start at the far right side and work your way back. Too much work, and it sometimes ends up being wrong. You figure out where your number needs to stop, look at the next digit only. If it's 4 or less, round down. If it's 5 or greater, round up. Only round the final answer. So if we're going to round 2.33 to 2 significant figures, we're going to keep the 2 and the first 3, and we're just looking at this guy. It's less than 5, 4 or less, and so it rounds down to 2.3. Because it's closer to 2.3 than it is to 2.4. 2.37, if we're going to round to 2 significant figures, we're going to keep the 2 and the 3. We look at the next digit. This one's closer to 2.4. The 7 is 5 or greater, and so we round up and we get 2.4. Okay. So let's do these calculations. If you have your calculator, pull it out and do these along with me. Because I make mistakes, and it's really fun to catch the instructor making a mistake, right? So that's a little game you can play with yourself. 1.10 times 0.512 times 1.301 times 0.005 divided by 3.4. And I press equals. I recommend just writing down everything your calculator gives you. So I'm getting 0.001077534. Did anybody else get that result? That 0.001077534. Okay, if you got a 1 at the end, that maybe means your calculator will show more digits. There's a lot of digits in that operation, right? It's really easy to press one button incorrectly. It helps if you have a calculator that will show you what you actually punched in. But I'm looking at mine and it looks like I did it correctly. What I recommend doing, because getting the right answer is pretty important, punch it through your calculator, write down what it says. Punch it through again. If you get the same number, you probably did it correctly. If you get a different number, that means you probably messed up somewhere. Sometimes you push the 1, but it doesn't actually register, or it'll register twice. Stuff like that happens. So if you get 2 different answers, do it a 3rd time and go for best 2 out of 3. Okay, so we've got an answer. We have to round this to the correct number of significant figures. We're multiplying and dividing. Those use the same rule. So what we need to do is identify how many sig figs in each of these numbers. So how many in 1.10? And in 0.512? And in 1.301? 0.005? 1. Leading zeros don't count. And 3.4? 2. And then we look at those numbers, which one's the smallest? The 1 is the smallest. That tells me I should round my answer to one significant figure. That's not going to be 0. Because these leading zeros are not significant figures. This is I have to keep one sig fig. That's going to be this 1. And then I look at the next one to see whether I round up or I round down. In this case, I'm going to round down, and I'm going to get 0.001. Any questions? It's a good idea to write down the whole thing and then write down the rounded number. If you come back later and realize, oh, shoot, I was thinking about that wrong, I rounded it off incorrectly. If you've got the original number written down, you can just change the number of significant figures real easily. If you just wrote down this final answer and not this intermediate with all the extra digits, then you have to do the whole calculation over again. Personally, I don't like doing things over and over again. Any questions? Let's do another one. So 4.562 times 3.99870 divided by 89.5 equals. Again, my calculator is showing me a mess. Anybody else get that? No? Oh, look at that. Yeah. I did something wrong. See, this happens. That's why I ask you guys to help me out. 562. I got pi in there somehow. I'd like some pi, but yeah. Okay, so here's my second attempt. 0.203822004. Anybody get that? Yay! I'd like to say that I make mistakes intentionally to see if you're paying attention, but it isn't true. I just flat out make mistakes. Because that's what the calculator says. Now, you do not have to go through and write all these digits down like that. Once you become comfortable with it, you can just look at them and you say, this has the fewest number of significant figures. Right? This one has 3. But let's go ahead and write them down. The first one has how many? 4. And the second one has 6. And the last one has 3. 3 is smaller, so we need to round this to 3 significant figures. The leading 0 doesn't count. 203. We're going to keep 3, and we're going to get rid of this one. That one's 5 or greater, so we're going to round this up and say this is 0.204. There is uncertainty in our result because there was uncertainty in the numbers we got the result from. Questions? How about adding and subtracting? So here's the rule. The result carries the same number of decimal places as the quantity carrying the fewest decimal places. So these rules are similar, but they're not the same. Multiplication, division, the answer has the same number of sig figs as the factor with the fewest sig figs. In adding and subtracting, it's the fewest number of decimal places. So if I do this calculation here, I've got 5.74 plus 0.823 plus 2.651. I'm going to write down what my calculator gives me. Did I do it right that time? Okay. Phew. Let's look at these 3 numbers. How many decimal places? By decimal places, we mean digits to the right of the decimal place. So this one has 2. and this one has 3 and 3, right? So 2 is the fewest number of decimal places. So we want to keep 2 decimal places in the answer. And we say 9.21. So let me explain that to you a different way. So I'll change pen colors here. In the number 5.74, which digit is uncertain? The 4. It's always the last one. That one's uncertain. In 0.823, which digit is uncertain? The 3. And in 2.651, the 1. So let's think about this then. If we were going to do this the hard way, just using our heads, right? We'd start on the far right and we'd take a 1 plus 3 and we'd get 4. But are we certain about that 1? No, it could be a 0 or a 2 or possibly even a 3. We're not sure. There's uncertainty. And we're not certain about that 3. Can we be certain about the 4 then? No. No, we can't. And what's this number here after this 4? We have no clue about that one. So that 4 is definitely an uncertain number. Here we have a 4 in the hundredths place. Are we certain of that? No, there's some uncertainty there. And then we're going to add this 2. Are we sure it's a 2? Yeah, we are. And we're going to add a 5. Are we sure it's a 5? We are. But we're adding this to a 4 that we're not certain about. So then when we get 11 as our answer, are we sure about that 1? No. There is uncertainty in this 4, and there's uncertainty in that 1. Let's look at the next place, 7. Are we certain of that? Yeah? 0.8, are we certain of that? Yep. Are we certain of the 6? Yep. So when we add those together, are we certain of this 2? Yes, there's no uncertainty in the 2. When we add things together and record the answer, we record all the certain digits in just the first uncertain one. So that's why that rule works. Let's do this other example real quick. 4.8 minus 3.965. Calculator says 0.8346. I didn't line those up very well. How many decimal places does the number with the smallest number of decimal places have? 1. And so we should limit our answer to 0.8. Another way to do this is to look at these numbers and draw a line to the right of the number that ends first. And that tells you where your answer should end. We'll pick this up next week.